Hello everyone. In today's video, we'll talk about binning method, which is used in data mining to smoothen out noisy data. The whole concept behind this method is, suppose we have a given set of data, we create smaller bins or clusters and fill those with the data from the given data, and then the data is processed in those bins, which is then smoothened out in smaller batches. So one of the big things that we have to take care in a question related to data binning is that we can either be given number of bins that we would create to be filled with the data, or we could be given bin size, also known as bin depth, which tells us how many data elements would be in each bin. So suppose if in the question we are given that we have to create 6 bins for a given data set with 12 elements, each bin will have 2 elements. Or in other type of question, we could be given a bin depth or bin size, and that would tell us how many elements will be in each bin. So suppose we were given a bin depth of 3, each of our bin will have 3 elements, and we would require 4 bins to take care of those 12 data elements from the actual data set. Let's look at an example to understand how to solve a question related to binning method. So say we are given a question where we are asked to use binning to smoothen the given data using given bin depth of 4 and use the bin mean method. So actually binning method has two variations which can be used to smoothen out the data. One is bin mean method and the other is binning by boundaries. So we would be always be given in the question which variation of the bin method we are supposed to use. So as we can look in the question, there are 3 parts to it. First is the data itself. Second would be the bin depth or the number of bins, and the variation we are asked to use. So we'll use both the variations to solve this question so that you know how to use either of those. But in either of the case, the first step would always be to sort the data out. Suppose that was our given data. After sorting, it would look like that. And then we create bins of the given bin size in the order of the element in the order that they appear in the sorted string. So now if we look at the bin mean method, it is pretty simple. We just take each and every element in a given bin and then find its mean and reassign that to all the values. We do that with each bin, and finally we get a new new smoothened data array which has much less noise compared to our original data string. Now, if we were to use binning by boundaries method, we look at the boundary values, which is the first which is the minimum and the maximum value in a given bin, and then for each of the elements inside the bin which is not at the boundary, we try to find out if it's closer to the minimum or the maximum value, and then we reassign the value of the boundary closest to the element to that particular element, and we do that with all the bins, and we assign the closest boundary value to each of the element that is inside and not at the boundary, and the data array that we get after processing is once again much more smoother as compared to the given data element array. Now, one thing to take care here is if we are given if the values inside a bin are such that the middle value is equidistant from either of the boundary, we can just leave it like that. So suppose we had values like 1, 3 and 5. So 3 has equal distance from 1 and 5, which is 2. We can just leave the bin the way it is. And that, my friends, was on the binning method. For more such videos, please subscribe to the channel, and if you like the video, please hit the like button.